Hi, I'm Derek Briggs, Tsugami Product Manager. Today, I'll be demonstrating when and how to utilize composite control functions in the Tsugami Swiss Type Lathe. Let's get started. So in the Swiss world, in the world of multi-path control, 2-path, 3-path, whatever it may be, there's a lot of ways to do very intricate work and very unique work, and that is by synchronizing paths and synchronizing axes, or using composite control to transfer control of axes from path to path. Synchronization and composite control are completely different, but they can be used in similar ways. This video is going to be about the composite controls. There is another video for synchronization control as well. So they are different, and I'm going to explain how composite control works in this one. So we'll start there. So with a 2-path control, you have NC1 and NC2, and we're going to separate that. And this is going to be X, Y, and Z1. Let's draw a line here. And X, Y, and Z2. Now some machines may not have a 6th axis. Maybe they don't have this Y2, something like that. Maybe it's a 5-axis machine. But for the sake of the video, we're going to call it a 6-axis machine. And this is composite control. And what composite control does, it doesn't necessarily synchronize 2 axes, one from each path. It actually gives the coordinate system of one path to another one of a certain axis, okay? So on a Tsugami, for example, if we say M231 and M231, these act as weight codes. Once both of these read M231, this path 2 will sit on M230, and this acts like a weight code. Okay? So this is waiting to cancel, and what this has done, this is called X1, X2 composite control. So that's what M231 does. So once both paths hit this, what this does is take X2, which is the x-axis for NC2, and gives control of it to NC1. So now X1 is no more while this is active. Now all my X moves are moving X2 axis. So now I'm controlling X2, Y1, and Z1. All while this is active. So all of my moves while this is active until I cancel with M230 are going to be X2, Y1, and Z1. And it's going to take the whole coordinate system from path 2 for X and give it to path 1. It's exactly as though you were programming X2, but it's actually being programmed in path 1 and controlled in path 1. So an example of when you would want to use X1, X2 composite control, and there's also Z1, Z2, and some other ones as well, is if you wanted to, say you had a boring bar attached to your sub-spindle. So we have, on some of our Tsugami machines, we have a deep hole drill block, and you can put a boring bar in there. So I would park my Z2, which is my sub-spindle, with my boring bar in front of Z1. And I'm going to feed Z1 out and move X2, because my boring bar is attached to the sub-spindle, to create a feature on the ID of a part. So I would actually be feeding Z1 and X2. And that's exactly what I'd be doing here, Z1 and X2. So I'm controlling sub-spindle X movements, but I'm moving my material into my boring bar all at the same time. And that's a perfect reason to be using X1, X2 composite control.